Okay, in this video, we're going to go through all of the problems on this day 2 of practice. So this says angle theta is an acute angle in a right triangle where tan of theta equals 4/7. Okay, so let's see how we're going to do this. First thing you've got to do is draw it. If you don't draw it, you put yourself at a distinct disadvantage. So I'm just going to turn on my little pen. I'm going to draw it right over here. Okay, so go. All right, so this is a right triangle. Now it says angle theta is an acute angle. Okay, I'm just going to put it down here. And then I know it's in a right triangle. I took care of that. Where tan of theta is 4/7. So remember SOHCAHTOA. That is going to really help you. And if it helps you to write it out, I would always do it. So from angle theta's perspective, tan is 4/7, which is opposite 4 over adjacent 7. Okay, so you are missing the hypotenuse. But because of Pythagorean theorem, we know that the hypotenuse is the biggest side. So what we know is that c squared equals a squared plus b squared. A squared and b squared are the legs. So I'm not even going to put labels on my triangle. I'm going to know that this means that the hypotenuse squared equals leg squared plus leg squared. And the hypotenuse is always directly across from the right angle. Okay, that being said, I'm looking for my hypotenuse. I'm going to call that c squared. So my two legs, the order does not matter. 4 squared plus 7 squared. That's going to equal 16 plus 49. Okay, so we're going to do that math. So if you have 16 plus 49, I'm getting 65. So 65, what is 65? Well, 65 is c squared, but we do not want c squared, we want c. So c equals radical 65. Okay, so let me just see one thing. Okay, so you cannot make that simpler. That's the best we're going to do. Right here, I'm going to put radical 65. Okay, now let's keep reading the question. We had to do this to get a missing side. Find all 6 trig ratios for angle theta. Provide exact answers, and I'm going to tell you you've got to rationalize where needed. So what we're going to do now is we're going to say, I think I'll do it here, sine of theta, and it says find all 6 trig ratios for angle theta. Okay, so sine theta, cosine theta, tan theta. Across from sine theta, I'm going to put cosecant theta because that's its reciprocal partner. Cosine across from cosine is going to be secant theta. Across from tan is going to be cotan theta. Okay, so now let's find sine. So from this angle's perspective, sine is opposite over hypotenuse. This is the opposite. This is the hypotenuse. This is the adjacent from angle theta's perspective. Okay, so the sine being opposite over adjacent, opposite over hypotenuse, is going to equal 4 over radical 65. Do not rationalize yet because, I'm just going to pull this down a little bit so that it's not so congested. And I'm going to take, let me just clean this up because we just lost my 7. And I'm going to put that back in over here. Okay, we're back to where we were. Okay, so don't rationalize yet because you know that cosecant is the reciprocal. So that's radical 65 over 4. Okay, cosine is adjacent over hypotenuse. So from angle theta's perspective, adjacent is 7 over hypotenuse radical 65. Don't rationalize it yet. We're going to take radical 65 over 7 and write in secant. Okay, tan they told us already is 4/7. This is a good time to make sure that you have drawn it so that it really is opposite 4 over adjacent 7. So I know we're good, and therefore I know everything else is good, and I know that the reciprocal of tan is cotan. Okay, so that's what we have. Now we've got to do some cleaning up. So let me just move this over just a tad because I want to rationalize. So I'm going to change my color. I'm going to multiply by radical 65 over radical 65. I'm going to do that 2 places. I'm going to do it where I have a radical 65 in my denominator. Multiplying straight across, that's a 65. 7 radical 65 over 65, and we are done. So those are all our answers. Okay, so you should be getting, this is the final answer, final answer, final answer, final answer, final answer, final answer, and we had to get this in order to start our problem. Okay, so you should be able to do that. If not, go back through that. Okay, another drawing. This one says, angle beta is an acute angle in the right triangle such that cosine of beta is 7/10. Find all 6 trigonometric ratios. So I'm going to draw my triangle again. Remember, the acute angles are not the right one. So here's my right angle. Across from that is always going to be the hypotenuse. I'm going to put beta down here, so I just tend to do that. And I'm going to write SOHCAHTOA right here so that it's right in front of me. And they gave me cosine of angle B, and cosine is adjacent, so this must be 7, and this must be 10, because it's adjacent over hypotenuse. Okay, so we're going to do the same procedure we did a second ago. I am missing this value. I can't start my work until I get that value. So what do I know? I know that c squared equals a squared plus b squared, Pythagorean theorem. The c side is always the biggest. I always find it by drawing that little angle. So 10 squared equals, this order doesn't matter. I'm going to make this x just to have a variable. Okay, so this is 100. This is 49. Notice I'm not solving the same way I did in the previous problem because I am not looking for the hypotenuse. Okay, so take 49 from 100, you should get 51, right? That equals x squared, not x. What does x equal? X equals radical 51, and I'm going to put that right here. So let me erase everything I have here so it doesn't look so cumbersome. And why don't I change my color so that you know I had to solve for this, and this side is radical 51. Okay, now we're ready to find all our 6 trig functions. So what do I need? I need sine of beta, cosine of beta, and then I need tan of beta. Across from sine, what I'm going to do is I'm going to say sine goes with cosecant of beta, cosine goes with secant of beta, memorize these, tan goes with cotan of beta. Let's get our values. So from this angle's perspective, angle beta, I see that sine is opposite. Opposite is going to be root 51 or square root of 51 or radical 51 over hypotenuse, and the hypotenuse was given to us as 10. Okay, don't rationalize. You don't need to. Just leave it be. Next thing, cosine of beta. So looking at cosine of beta, I know that cosine's adjacent, which is 7, also over hypotenuse. Everything's beautiful there. Okay, tan. Tan, what's that? Opposite, which is radical 51 over the adjacent, which is 7. Okay, so I have the 6 or the 3 main functions. Now go ahead and get the reciprocal function. So maybe I'm going to pull up this triangle and move this just a little tiny bit. Put that right over there. Okay, so cosecant is the reciprocal. it's 10 over radical 51. Secant is the reciprocal. It's 10 over 7, because I just flipped those. And cotan is going to be 7 over radical 51. Now you look and you say, where do I have to rationalize? You have to rationalize wherever you have a radical in the denominator. So, and I need to do that triangle one more time. Okay, so that means that I'm going to get 10 radical 51 over 51, leave it be, and then here rationalize. Remember, rationalizing is a multiplication type event. Okay, and that's what I get. So what are my answers that they asked for? This one, this one, this one, that one, that one, that one. And remember, we had to solve for the missing side in order to get us started. Okay, so those are two nice problems. Okay, so then we look over here, and this says, solve each triangle below, round to 1 decimal point with your calculator. So that means you might as well take your mode off of float, and so go from float to 1. Keep the angle in number 4 in radians. Okay, so number 3 is not in radians. So I'm going to grab my calculator. I'm going to go to my mode. I'm going to put float on 1, and I'm going to make sure I'm in degrees. Now I'm ready to go for the first problem. Well, what about this angle? Oops, so sorry. What about this angle right here? This is a 90-degree angle because it's a right angle. So I know what that is already. You're not really solving for it. I just identified what it was. So that means angle A and angle B are complements. If they're complements, they sum to 90. So to find angle A, take 90 minus 34. And if you say 90 minus 34, you're going to get 56 degrees. So this is 56 degrees. Okay? So that's part of solving for the triangle. What's the other part? I need to figure out A, and I need to figure out C. Now, why do they have these little letters? Well, look at the capital letters. The capital letters are always your angles. The little letters, the baby letters, are always your sides. So you know, for example, that 26 is B because it's opposite B. So we need to find all the missing sides. So you have some options. So let's see what we should do for options. I know that I have 2 angles to work with. You never work with the 90-degree angle. You always work with the acute angles. So if I want to find the hypotenuse, I could say, let's think about SOHCAHTOA. From angle B's perspective, I have opposite. I need hypotenuse, and I need the adjacent. So I'm going to focus on angle B, okay? So I'm going to say that the sine of angle B, but I'm going to put the sine of 34 degrees because that is angle B, equals opposite, which is 26, over some missing hypotenuse. This is your cross product. So you're going to say C times the sine of 34 equals 26. So therefore C equals 26 over the sine of 34. And my calculator goes 24 divided by the sine of 34. So I waited to the last step. That's going to give me a value for C of 42.9. So I'm getting C equals 42.9. Okay, so remember, C is the hypotenuse. So let me write this in as 42.9. Okay, now let's get the adjacent. I'm going to still keep dealing with angle B. So I know that the adjacent over, or that the opposite over adjacent, I always use the numbers they give us. So I'm going to say the tan of 34 degrees equals 26 over A, because that's opposite over adjacent. Look how I labeled my triangle. Do your cross products. A times the tan of 34 equals 26. And then I want to get A by itself. So A equals 26 divided by the tan of 34. And that goes in my calculator. So 26 divided by the tan of 34 equals 38.5. So A equals 38.5. So this is 38.5. Now we're going to do the reasonableness test. What has to happen is the hypotenuse has to be the greatest. That's good. So that makes reasonable sense. Other thing that has to happen is the adjacent side, which is opposite a bigger angle, should be bigger than the opposite side, which is opposite a smaller angle, and it is. So I am happy with my answer because it passed the reasonableness test. And now we're ready to do the other problem that deals with radians. Okay, so let's get this squared away. So look at what we have here. They are telling you this should be a right angle here, so put this little right angle in the corner. We wanted to say that they're both right angles. Okay, angle A and angle B are also complementary. So to get angle B in the previous problem, I said 90 minus 34. I'm now dealing in radians in problem 4. So my 90 degrees equals what? You should all be screaming pi over 2. Okay, so if that's the case, then I know that pi over 2 minus pi over 10 is what I need for angle A. Well, I can't do that unless I multiply pi over 2 by 5 over 5. Okay, that gives me 5 pi over 10 minus pi over 10, which is 4 pi over 10, which reduces to 2 pi over 5. And that's what angle A is, and that's what I mean by keeping it in radians. Don't put that in your calculator. Keep it just like it is. Okay, so now I'm going to use this angle because they gave it to us. From this angle's perspective, we need the opposite and we need the adjacent. So let's see if we can get the two missing sides. Okay, we're not doing all the trig ratios, we're getting missing sides. So let's think about this. Why don't I try to get the opposite first? That's going to be opposite over hypotenuse because I've been given the hypotenuse, right? So I can say that the sine of pi over 10 equals b, which is unknown, over 13. Now, before you grab your calculator and start hitting numbers, you've got to go to your mode. Go to your mode, and you have to change from degrees to radians. That is key. If you don't do it, you're going to get the wrong answer. So I'm going to say mode equals radians here. It's not a bad idea to write this down for yourself. And this is mode equals degrees. Okay? All right, so now that I'm in radians, I'm still rounding to the nearest tenth, so that's okay. What will I do to solve this problem? Well, this is just cross products. So 13 times the sine of pi over 10, and I recommend that you close your parentheses, is going to equal b. That just goes in my calculator. 13 times the sine of pi, which is second caret, divided by 10, close parentheses, equals, and that's going to equal 4. So b equals 4, which seems reasonable. So that is 4, and that is one of my answers. I should go back quickly and highlight these answers for you. Okay, So now we're done with that. We have b is 4. That's a happy thing. Okay, and I put it over here as well. So now let's get the adjacent side. So coming down here, I say I'm going to use that same angle. And if we're dealing with adjacent over hypotenuse, that's cosine. So cosine of pi over 10 equals a over 13. So take your 13 and multiply it here. You can do cross products, or you can just do what I just did. And I'm going to put in my calculator. I'm just going to do 13, and then I'm going to say not sine this time, but cosine of second pi divided by 10, close parens, and I am getting that a equals 12.4. So that's what a equals. I can highlight that, and I can also come over here and put it right here and highlight that. Now, is this a reasonable answer? Well, I think it is, because the hypotenuse has to be the biggest side. It is. The angle pi over 10 is smaller than 2 pi over 5. So the side opposite it should be smaller than the side opposite 2 pi over 5, and that's what I have. So I know my answers are reasonable, and I can move on. Okay, so this is a diagram that says below to solve each of the two triangles. So you're going to use this diagram. I have all kinds of color going on here for a reason. Each length that you need to compute is given a different color in the diagram. Round the lengths to 1 decimal period. Okay, so I'm looking at the problem, and I'm seeing I have everything in degrees. So I'm going to go into my mode before I forget and change it into degrees. Okay, so next thing, I'm going to start solving some angles. If it's helpful to you to write in 90 here and here, do it. Okay? If I know that I have a toe angle down here of 33, then I know the angle up here is going to be complementary to it. That means that 33 plus something is going to equal 90. So take your 90, subtract away 33, and then this angle right here is going to be 57 degrees. Okay, maybe what I'll do is I'll put it right inside so you can see it. So this angle is 57 degrees. Okay, what else do I know? Well, if this angle is 41 and the other angle is 90, then that means that I can figure out the complement to 41 by saying 90 minus 41, and that gives me 49. So now I have that. Okay, so you need some missing sides. I'm going to need this, I'm going to need this, and I'm going to need this. So I would think that, oh gosh, and I'm going to need this right here. Okay, so let's see what we're going to do. Let's work with the triangle on the left side first. So we're going to focus on this triangle right here. And I'm going to try to get these two values. And I'm going to use 41 degrees to do it because they gave me that. Okay, so I'm going to use 41 degrees. So from 41 degrees perspective, what is the only thing I have? I only have hypotenuse. So I'm going to say SOHCAHTOA. So I just have it in front of me. And I'm going to say, okay, I've been given the hypotenuse. So therefore, I'm probably going to use sine and cosine to find the missing sides. So let's do that. Okay, sine of 41 equals opposite. Let's make this an x. So opposite over hypotenuse. And that's nice because look what happens when we do cross products. It is a one-step problem. Once you do this, you get that. So remember, I'm in degrees. If you didn't change your calculator, you definitely want to do that. Okay, 23, times the sine of 41, close parens, and I get 15.1. So here's my first value. and it's going to be x equals 15.1. Okay, so let me clean this up a little bit. Give myself some space. So I'm going to say that this right here was x, and x equaled 15.1. Okay, and what I should do, I should be clever here, because I'm allowed to be clever. Why don't I match the color with the color we're looking for? How's that for clever? Okay, so this is going to be x equals 15.1. So now I know that that goes with this. Okay? Okay, so let's get the orange side. So I'm going to say that the sine, excuse me, I'm not going to say that. If I'm going to try to get that orange side, it's going to be cosine. The cosine of 41 equals, let's make this a y. It equals y over the 23. Same thing's going to happen. You're going to do cross products one time, and that's going to get you your value. So what I could do here is I'm going to say second entry. That pulls up the exact same line I just did. And I am going to change the sign to cosine. So now I have 23 times cosine 41, and I'm getting that y equals 17.4. So this is kind of orangey. So let's make this 17.4. Okay, and that's going to be this. Okay, so we've got two more sides. That 15.1 is going to get used again because I don't have any of the other sides in that triangle to the right, and that's why I had to start with the triangle on the left. Okay, so I picked wisely. I want you to do that as well. They gave me the angle 33. I'm going to use that. So I need to get, let's say, this is Z, and let's make this, I don't know, little p. Okay? So from angle 33's perspective, I have opposite, I need hypotenuse, and I need adjacent. So let's do the Z first. So I'm going to do opposite over hypotenuse. So I'm going to say that the sine of 33 equals opposite, which is 15.1, over hypotenuse, which is Z. So two-step problem, Z times the sine of 33, doing cross products, equals 15.1, that's step one, divide by sine 33, divide by sine 33, and you will get your Z. So Z equals 15.1 divided by the sine of 33. Boom. Oops, I didn't do that right. 15.1 divided by the sine of 33. Okay, so that's going to be 27.7. 27.7. Okay, last side is the adjacent side, so I'm going to use cosine. So we're going to say that the cosine of 33, cosine of 33 equals adjacent, which is P, over 15.1, which is the hypotenuse. So you're going to do your cross products, one-step problem, and I'm going to say 15.1 times the cosine of 33. Okay, so watch what you enter because it's really easy to type something incorrect given all the numbers we're typing. I'm getting 12.7 here. This is 12.7. And if I did a reasonableness test, I believe it would all work out. Okay, but that's what I'm getting for all those answers. Okay, so let's go back and let's go on and see what we have left. We've got two more problems. Okay, so this says a circle has its center at C. So that's right here. And a radius of 18 inches. Okay, so this is 18. And I also know that from here to here is 18. If triangle ADC, so that's the whole triangle you see, is a right triangle, and angle A is 35, find X, which is the distance from A to B. Oh, that's a kind of interesting problem. So if I know I have this angle, correct? If I have this angle, and I'm trying to find X, what do you think I should do? This is what my thought is. I'm going to make this into a different brand new variable. I'm going to call that Y. And from 35 degrees perspective, now am I still in degrees? Yes, I am. I'm good. So from the 35-degree angle perspective, I have opposite, I need hypotenuse. I need part of a hypotenuse. So I'm going to say sine of 35 equals 18 over y. Now, why am I doing that? The key to this problem is, if they tell you that this is the radius, you need to recognize that this piece is going to be exactly the same. If you don't recognize that, you're not going to get the correct answer, because there's no way you're going to get to X. So I did that piece pretty quickly. That's why I'm going back and making sure that you get what I just saw. So cross products, y times the sine of 35 equals 18, and y equals 18 divided by the sine of 35. So I'm in my calculator. I have 18 divided by the sine of 35, and I get 31.4. Now, we're not looking for y, are we? So my y is 31.4, but isn't that 18 plus x? So why not just subtract 18 from it? So 31.4 minus 18, and that's going to give me, let me do this correctly. When I do this, I get 13.4. When I do this, these go away, and I have x is 13.4, and that's a very nice problem. So make sure you understand that. Make sure you understand how radii inside a circle work. They're all the same length. Okay? All right, so we have another one that we're finding things that are missing. It says find the angles of, find the measure of angles A, B, C, D, and E. Okay, and everything is labeled, so we're good. And the lengths of the color-coded sides. Hint, get some of the angles before finding angle A. Okay, and that makes sense. So what can I do? I think the first thing I would do is just reinforce that this is 90 and this is 90. Okay, so what else do I know? Can't I now get angle B? Because I know it's a complement to that 19-degree angle. So to get angle B, you would say 90 minus 19. That gives me an angle right here of 71 degrees. Okay, so that's nice. What else do I know now? Well, it looks like I know that I have 42 degrees down here to the other side of the 71. So what about that? Well, guess what? These three angles right here are on a straight line. That means that they sum to 180. So why don't you say 180 minus 71 minus 42, and that's going to equal angle A. So 180 minus 71 minus 42, and that's going to be 67 degrees. So this angle A is 67 degrees. Okay, what else do we know? Well, we can figure out angle E, can't we? Because we have the angle 42 down below, so 90 minus 42 will get us its complement, which is 48 degrees. Then this is a rectangle. So what I know is that this is a right angle, and so is this. So we need more complements. So right now what I'm going to do is I'm going to find angle C. And to do that, I'm going to say 90 minus 19. Angle C is 71 degrees. So this is 71 degrees. Then let's find angle D. I can do that two ways. I know that angle A is 67, angle C is 71, and I know inside any triangle is 180 degrees. So I'm going to find angle D by saying 180 minus 71 minus 67. And when I do that, I get angle D is 42 degrees. And I have all my angles. So now we're able to do our sides. So let's see how we're going to do that. So what are your thoughts? So my thought is that I'm going to work at the bottom of the triangle. And the reason why I'm going to work at the bottom of the triangle is because I can figure out some of the pieces by using SOHCAHTOA, because I've got right angles. So let's take the triangle where I'm trying to figure out the two pieces. So I'm going to take this triangle right here, okay? Let's work that one out. So I'm going to come right below it, and I'm going to redraw it. Here it is. Right, sounds are optional. Put your right angle right there. This is 19. Copy carefully. This is 71. Okay, can I figure out anything? So from angle 71's perspective, or maybe I should use 19, because 19 I didn't get myself. Let's use that. So from angle 19's perspective, I have adjacent, and I need hypotenuse, and then I'm going to also need this leg. So, and that's going to be the opposite. So why don't I say first, let's see, why don't I say that the cosine of 19 degrees equals, cosine is adjacent, so that's 8 over, cosine is over hypotenuse, and my hypotenuse I will call x. Okay, so cosine of 19 equals adjacent over hypotenuse, because remember we want to do SOHCAHTOA. Okay, so that goes in your calculator. After you do this 12 million times, you're going to realize that if you just change the position of x and cosine 19, life is good. I'm still in degrees. I'm going to say 8 divided by cosine 19. If that's confusing for you, you can still do cross products and do it as a two-step problem. I'm getting that x is going to be 8.5. So this is 8.5. Okay, so that means that right here is 8.5. Done. Okay, I find that it's less confusing if you redraw the triangles, by the way. Okay, and we can probably get rid of, let's see, what can we get rid of? There we go. Let me get rid of this explanation because you've already seen it. Okay, so now let's try to find the bottom. To find the bottom, I'm going to say, I'm still going to use the angle 19, and now I'm going to do tan, because look, the tan of 19 degrees, what does that equal? That equals opposite, which is y, over the 8 that was given. Do your cross products, 8 times the tan of 19, and you get 23.2. So down here is 23.2, and so is this. Okay, now why don't we work in the triangle to the right. So that means that we're going to work in, hang on, let me just change my thing to that. Let's work in here. okay, in that triangle. So working in there, I'm going to redraw it over here. And what kind of things do I have? Well, I know this is 8. I know this is, it's 48 on the top there. And I know this is 42. So I want, we'll call this Z, and we'll call this Q. And I should call it small q, so I don't want to do that. So let me just call this small p. Okay, so from this angle's perspective, because that was given to me, I'm going to say, I looks like I just have the adjacent, right? So I can say that the cosine of 48 degrees equals adjacent over the unknown hypotenuse. So, as I said, you can do cross products, or you can switch the position of P and cosine 48 and say 8 divided by cosine 48, and I'm getting P is 12. Okay, so P is up here. This is 12. This is 12. Okay, we've got 2 more to do. Let's get Z. From angle 48's perspective, I'm going to say opposite over adjacent. So the tan of 48 equals opposite, which is the unknown, over the adjacent, and that's just a simple cross products. So 8 times the tan of 48, and that's going to be 8.9. So Z equals 8.9. So Z is down here, and Z is here. Okay, now look at this. This is a rectangle. By definition, it means that opposite sides are congruent or equal. So I needed the 2 colored sides. The darker color brown is 23.2, and the blue color is 8.9. To get this orange above, I'm just going to add those 2 together. 23.2 plus 8.9, and that gives me 32.1. And I believe, looking around, that we are done. Okay, so make sure you can do this because it's a great problem. And that is the last one. So thank you for watching. I hope this helped you.